On the next set of problems, replace the polar equation in set 27 through 52 with equivalent Cartesian. That means change it to x and y. And again, in case you've forgotten, we only have 4 formulas. We have r sine of theta. Isn't that a y? I'll write them here. We have r squared equal x squared plus y squared, and tan of theta equal y over x, and x equal r times the cosine of theta, and y equal r times the sine of theta, and there it is. So r sine of theta, isn't that a y equal? We could graph this, but they're saying describe or identify the graph. Well, we're saying this is a line, right? And r cosine of theta isn't r cosine of theta x. So the equation r equal cosine of theta is nothing more than x equals 0, also a line. And there is no secant. There's only 4 of those. So if I manipulate the problem a bit and say that's 3 over cosine of theta, cross multiply, and I know that r cosine of theta is x, and that's also a line. If I get to number 34 and I try to work that out, we'll say, well, hey, look, that is y, that is x. Hey, isn't that a line cutting the plane at 45 degrees? So I know what that is. And how about 36? Well, isn't that x squared plus y squared equal 4? And isn't that y? Now, isn't that saying x squared plus y squared minus 4y plus, take half of the middle number and square it? Wouldn't that be x squared plus y minus 2 squared equal a 2? Isn't that a circle with a center of 0, 2 and a radius of 2? I meant that to be a 4. And if I look at this, isn't this twice sine of theta cosine of theta equal 2? And that is r squared. Wouldn't the 2's cancel out? Can't I split the r and say that's r times the sine of theta, r times the cosine of theta equal to 1? Isn't that y, and that's x equal 1? Isn't this y equal 1 over x? And I know what that looks like. That's one of these graphs. So these are the graphs that make sense for us. The rest of this part of the homework, up to 52, is going to be an expression, but it's not going to make much sense, and we're not after that. We want to go the other way around before I get to the last part, which is graphing, the most crucial part. And now if I want to go from x and y to r and theta, the same deal. Well, y, that's r sine of theta equal 1. Keep in mind, you know how we have y equal f of x? In polar land, we have r equal f of theta, which means you get r on one side, everything else on the other side. R will equal 1 over the sine of theta, which is the secant of theta. Now, for the test purposes, I don't mind you, once you eliminate x and y out of the equation, you're done. I don't need to clean that up. For 56, isn't that r cosine of theta minus r sine of theta equal 3? Now again, on a test, you're done right here. No need to do any extra work. But for the homework, you want to match it at the back of the book. So this is r into cosine of theta minus sine of theta equal 3. And if I divide, because I want r by itself, that will be 3 divided by the cosine of theta minus sine of theta. And here I will say, be careful, x squared plus y squared is r squared, not minus. This is r cosine of theta squared. This is r sine of theta squared. Again, on a test, this is more than enough. That's all I want. You need to know that for the next class. That's why I'm emphasizing those. If I get r squared cosine squared of theta minus r squared sine squared of theta equal 1, I factor r squared out. That's cosine squared of theta minus sine squared theta. I don't know if you are aware that this is cosine of 2 theta. If you divide both sides by cosine squared, you will get r squared equal 1 divided by cosine of 2 theta, which is secant of 2 theta. And here, if I take r cosine of theta, r sine of theta equal 2, this is r squared times sine of theta cosine of theta equal 2. So if I divide both sides by sine and cosine, r squared will equal twice the cosecant of theta secant of theta. Again, on a test, this is more than sufficient for me. And I want you to pay close attention to the following example. This is really r squared equal 9. And if I square root both sides, r will equal plus or minus 3, makes no difference. So, I know this is a circle, center at the origin, and the radius is 3. R equal 3 or equal negative 3 is a circle centered at the origin with a radius of 3, something that we're going to be playing with next. So if I look at the graphs 12 through 22, so keep in mind r equal 2 I know is a circle with a radius of 2. So r equal 2 is this circle. R equals 0 is this point. When you say r is between, so r equal 2, you stay on the circumference of that circle. If r is bigger than 2, you would go outside of that circle. R is less than, you go inside of the circle. I'm going to add something at the end. Here, this says r is bigger than 1. Well, there's 1. There's 2. It's saying r is between. R is between 1 and 2. It turns out if you want to use circles, polar coordinates are a lot more efficient than rectangular coordinates in so many ways. Now, when I get to number 16, I noticed that they fixed the angle. They rotate. Oh, how did that happen? Let me fix that really quick. There. They rotate to 2 pi over 3. Well, 2 pi over 3 is right there. So now I'm fixed on that line. And they say if r equals a negative 2, there's 2 pi over 3, there's negative 1, negative 2. It says r is less than. It's saying r is less than. What do you think that means? Less than negative 2. If I say less than negative 2, there's negative 2. If I say negative 3, isn't this 2 pi over 3 negative 3? Negative 4? Do you see that you end up tracing that piece of the line? Those are crucial to get accurate. You can't really be hazy about those. Here, I'm looking at 11 pi over 4. 11 pi over 4 is way too big. If I count 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5, 6, 7, 8, 9, 10, 11 pi over 4 is right there. Or, I could say take 11 pi over 4 and subtract 2 pi from it. Remember, you could add or subtract 2 pi. That will be all over 8. 3 pi, over 4. That will be 8. 3 pi over 4. You're still right here. If r equal negative 1, you are right here. R is bigger than negative 1. So 0 is right there. R equal 1 is right there. Do you see that you trace this piece of the line? And if I move to this problem, we're rotating to pi over 2. There's pi over 2. R is less than or equal to 0. R equals 0, I'm right there. r equal -1, -2, -3. Do we agree that we trace the negative y-axis out of this? And if I move on and look at the last graph before I give you one, if we have r equal -1, aren't you really stuck? R equal -1, aren't you stuck right there? But then they have theta running from 0. Well, 0, -1. Isn't 0, -1 right there? Rotating to pi. If I go pi over 4, -1, pi over 2, -1, 3 pi over 4, -1, and pi, -1. Do you see that you're only tracing the bottom half? Only the bottom half of that circle? The last two problems I want to look at out of this section would be problem number 24, which says r is between -1 and 2, but theta is fixed between -pi over 4, there's -pi over 4, to pi over 4. So if I go from -pi over 4, let's say, right there, and I say r equal -1, isn't that -1? 0, isn't that 0? 1, isn't that 1? So do you see you're tracing that line right there? And how about theta equals 0? Well, 0 is there. R equal -1, R equal 0, R equal 1, you're tracing that line. But do you see that this is continuous, all of those? So far you traced all of that region. And as this continues up, do you see that you trace all of this? And you run down all of this. Right? Like one of those Avengers, like Spider-Man's, well, somewhat. It's not wrong, perfect. And how about this graph? R equal 1, I am on that circle. R equal 1, I'm on the circle. But do you notice that R is not equal to 1? That circle is not included. Oh, I don't like that. It doesn't show that it's dotted. So let's make it dotted, solid dotted. There we go. And when you say R is greater than, R is less than, you're inside. R is greater than, you shade outside of the circle. So anything above, not to 3, all the way. Anything other than that circle. Alright? And there's the homework.